It is February 2026. And if you are anything like me, you are probably oscillating between being absolutely blown away by AI and wanting to just throw your laptop straight out the window.
Oh, yeah. That is a vibe I know very well. It's that specific feeling of it working like magic right up until it breaks like a cheap toy.
Exactly. It's this paradox we're living in. I call it the genius goldfish problem.
Yeah.
Because we have these agents now, these digital workers that can, they write kernel-level code.
Right.
They parse complex legal contracts in microseconds.
Hmm.
They can theoretically manage your entire calendar and workflow. The raw IQ is just off the charts. They're brilliant.
But they have absolutely no object permanence.
None. You close the tab and boom, total amnesia.
Yeah.
You essentially hire the smartest employee in the world,
Right.
but every single morning they show up having forgotten
Yeah.
your name, your goals, everything you agreed on yesterday. It drives me up the wall.
And you know that frustration, that exact headache you're feeling, that is actually the sound of a $100 billion opportunity. Yeah, because what you're describing isn't a failure of the AI model itself. It's a failure of the environment we're putting it in.
And that is exactly what we're unpacking today for you all. We're doing a deep dive into a really sharp analysis from Acalytica. It's titled, What AI Agents Want. The $100 infrastructure gap nobody is talking about.
It's a great piece.
It really is.
Yeah.
The premise is fascinating. But we spent the last 3 years obsessing over the brain, the models themselves, and we just completely forgot to build the office.
Right. We're taking these digital workers and just dropping them into a void.
Yeah.
The source argues that the next wave of tech giants, they won't be the ones building slightly better chatbots or, squeezing another 2% of reasoning capability out of a transformer. It's going to be the companies building the plumbing, the infrastructure that gives agents memory, a sense of time, and a way to actually work without breaking things.
So just to be super clear for you listening, we aren't talking about weights and biases today. We aren't getting into the abstract math of context window sizes. Our mission here is to look at the environment around the model.
Exactly. The missing layer between raw intelligence and the actual application. Because right now, that layer is basically non-existent.
Let's start with that goldfish problem you brought up.
Yeah.
Because I think sophisticated users out there might push back on this immediately.
Sure.
They'd say, wait a minute, we have context windows that are millions of tokens long now. We have RAG retrieval augmented generation. We've got vector databases.
Right.
Why are we saying agents have no memory? My agent can read a 200-page PDF I uploaded.
It's a totally fair pushback. And technically, yes, you can stuff an enormous amount of data into a prompt. But the article makes a massive distinction here between knowledge and experience.
Okay, unpack that.
So ARA is great for pulling up a static fact from a manual. But it's kind of like handing your employee a giant textbook and saying, read page 400 before you answer my question.
So our RAG is essentially reference, not memory.
Precisely. It is semantic memory, facts about the world. But it's not episodic memory. It isn't a diary. The source makes this point crystal clear. Current agents are stateless by default.
Stateless, meaning they don't carry anything over.
Right. When you interact with an agent, it's effectively a fresh blank instance. If you use RReg to inject context, you're just cramming the prompt with data for that one specific session.
Yeah.
You aren't giving the agent a continuous sense of self or a history of your interactions.
And doing that is expensive, isn't it? If I have to refeed the last 6 months of my project emails into the context window every single time I ask a simple question, I'm just burning tokens.
You're burning cache, you're adding latency, and you're losing fidelity.
Yeah.
But the bigger issue the article highlights is that the agent doesn't learn how to work with you. What agents actually need is episodic memory. It has to be structured and it has to be queryable.
How is that different from just, logging the chat history? Because I can save a JSON file of all my chats right now.
Well, a chat log is just a messy blob of text.
Okay.
It's unstructured data. Episodic memory, as described in this piece, is an agent-native database, a structured record of decisions and outcomes. It allows the agent to actually query its own past behavior.
Give me an example of how that looks in practice.
So an agent with episodic memory can pause and ask itself, what did I try last week that failed? Or, what preference did the user express about Python versus Rust 3 months ago?
Oh, that's interesting. So it's not just recalling a fact you told it, it's recalling cause and effect,
Yeah.
the actual process.
Yes. They call it a memory warehouse. Think of it as a curated model of the world that gets richer and more useful the more the agent works.
Without that, the agent is just trapped in this endless day one.
Exactly. It never gets better at its job because it can't learn from its mistakes. It makes a mistake, you correct it, the session ends, and tomorrow it makes the exact same mistake.
It feels like the difference between a freelance contractor you have to micromanage every single day versus a chief of staff who develops institutional knowledge over a year.
That's a great way to put it.
Like, my chief of staff knows I hate meetings before 10 a.m. without me ever having to say it again. The contractor needs to be told every single time.
That is exactly the shift we need. And the company that builds the standard protocol for this, the SQL for agent memory, so to speak, they're going to be indispensable.
Because once an enterprise starts building that history on a platform, they're locked in. They're never going to leave.
Exactly.
Okay, so that handles the past, but what about the present? Because this is the other thing that completely drives me crazy.
The hallucination tax.
Yes. I ask an agent about a stock price or some breaking news or new API documentation that literally just dropped yesterday.
And it hallucinates. Or it confidently gives you data from its training cutoff, which might be a year out of date.
Right. Or, alternatively, it tries to browse the web, and I have to sit there staring at a little spinning wheel while it scrapes 5 different websites, hits 3 paywalls, and gets confused by a cookie banner.
The source calls this exact friction the hallucination tax. It's the cost of agents trying to operate in a world they can't actually see. The metaphor they use in the article is just brilliant.
The archaeology one?
Yeah. They say an agent trying to understand the current business landscape by web scraping is like doing archaeology when it should just be reading the newspaper.
That is such a good image. Because the web HTML was built for human eyeballs.
Right.
It wasn't built for machine logic at all.
No, HTML is a terrible format for an AI. It's messy, it's unstructured, it's full of ads and pop-ups and formatting tags. The agent has to parse all that noise just to find the price of a single widget.
So what's the fix? The article argues we need a Bloomberg terminal for agent reasoning. Unpack that for us.
Well, think about the actual Bloomberg terminal. It's famous for being ugly to look at, but incredibly dense with raw, actionable data for humans.
Right.
Now imagine a low-latency, structured feed of truth built purely for machines. Real-time stock prices, updated corporate org charts, legal status changes, API uptimes.
But delivered how?
Delivered as a knowledge graph or a direct JSON stream, something the agent can digest instantly without having to parse a website's CSS.
So instead of the agent Googling something and reading an article, it just plugs directly into a feed of reality.
Yes, a source of truth infrastructure. If an agent needs to book a flight for you, it shouldn't be scraping Expedia's front page.
That's so fragile.
Very fragile. It should be hitting a dedicated, machine-readable travel ledger. If it needs to know if a company is solvent, it queries a financial status API directly.
This seems like a massive gap. We're forcing supercomputers to act like a person sitting at a desk browsing Chrome.
It is the single biggest bottleneck for autonomous agents right now. You simply can't trust an agent to execute a trade or sign a contract if its view of the world is based on a hallucinated fact or a cached web page. If the data isn't live and structured, the agent is flying blind.
You mentioned executing trades and signing contracts. That actually pivots us perfectly to the next layer of this infrastructure, which is trust.
Oh, this is where things get really wild.
Because we're moving toward a multi-agent economy, right?
Right.
It's one thing for me to talk to a bot. It is a completely different game when my bot hires another bot.
Right.
Let's play this out. Say I have a general manager agent running my business. It decides it needs a specialist to review a licensing agreement. So it goes out to the open market to find a legal agent.
How does it know who to hire?
I mean, I assume ratings, like a 5-star system.
But where do those ratings come from? Right now, the agent economy is the literal Wild West. There's no Better Business Bureau. There's no Yelp. There's no board certification for bots.
The source calls this the trust deficit.
Yes, it's an app store without any reviews.
That's actually terrifying if you think about it. If my agent hires a dud, I lose actual money.
Right.
Or worse, I get sued because the legal agent just entirely hallucinated an indemnity clause.
Exactly. So the article suggests we have to build institutional infrastructure for digital workers. Think about how we solved this problem for humans over centuries.
We use shortcuts. Degrees, credit score.
Bar associations, medical boards, background checks.
Right. I don't interview my surgeon for 3 days to test their medical knowledge. I just look for the board certification. I trust the institution that vouched for them.
We need that for agents. Digital credentials. We need a system of reputation scores, but based on cryptographically verifiable task performance?
Cryptographically verifiable. So not just 5 stars that a farm of bots can game.
Right, proof of work. If a coding agent claims it fixes bugs 99% of the time, the hiring agent needs to see the commit logs signed and verified on an immutable ledger.
And capability declarations, too, I imagine.
Yes, standardized capability declarations. I want to know immediately, does this agent have access to the public internet? Can it delete files? What is its maximum spend limit?
I could see a whole industry for agent insurance popping up around this.
The source mentions exactly that, escrow and liability layers. If your agent hires a sub-agent, and that sub-agent accidentally crashes a production database, who pays for the downtime? Is there a bond posted?
It's like we need a Visa or MasterCard network, but for agent work. A protocol that sits in the middle and says, yes, this transaction is verified, the worker is certified, and the task is insured.
Trust is a huge network effect. The first company to build a reliable credit score for AI agents will basically own the marketplace.
Because everyone will have to use it.
Exactly. Once you have a trusted reputation system, if you aren't on the trusted list, you just don't get hired.
Let's talk about the consequences of screwing up, because this is the part that keeps enterprise CIOs up at night. The source calls this the action problem.
This highlights the core difference between a chatbot and an agent. A chatbot talks. An agent does things.
And doing things is inherently dangerous.
Very.
The source makes a really insightful point here about how the human world is designed. It says our world is optimized for fallibility.
I loved that phrasing. Think about it. Almost everything you do in a corporate environment has a safety net built in.
You send an email, you can often recall it, or at least send an apology right after.
You order the wrong office supplies, you return them, you mess up a spreadsheet, you just restore the previous version from the cloud.
Right. We built undo buttons into reality because we know humans make mistakes. We expect error.
But agents don't have that context. They have no proprioception.
Proprioception meaning a sense of their own body in space, or in this case, the impact of their actions.
Exactly. They don't inherently understand risk or reversibility. If an agent hits an API endpoint that deletes a production database, it's just gone.
There is no "are you sure" pop-up for a Python script running autonomously on a server.
Right.
So what is the infrastructure fix for that? Because we can't just prompt the AI to be careful. That's like telling a toddler to be careful with a hammer.
We need rollback infrastructure. To use a more technical term, we need to enforce transactional behavior in the real world.
Like ACD transactions in a database. The whole all-or-nothing concept.
Exactly. Before an agent takes an action, the infrastructure needs to snapshot the state of the system. It needs to tag whether the action is reversible or irreversible.
So if the agent starts going off the rails, say it starts emailing every customer in your database with a hallucinated 90% discount code.
The system hits an emergency brake.
And it unwinds the damage.
A literal CRLZ for the real world. Without this rollback layer, no enterprise is going to let autonomous agents run core processes. They'll just stay as toys.
They can write poems and summarize meeting notes all day, but they won't be allowed to touch the logistics network.
Exactly.
But this feels like a massive technical hurdle. Building a rollback feature for software state is hard enough. Building it for real-world actions like spending money or sending physical mail seems incredibly complex. You can't unsend a wire transfer very easily.
It is incredibly complex. It might involve holding actions in escrow for a set period, or having a human-in-the-loop requirement for any action that crosses a certain financial risk threshold.
But that complexity is why it's a $100 billion opportunity.
Precisely. The layer that guarantees safety, that wraps every agent action in a reversible transaction, is the key to unlocking true enterprise adoption.
Okay, so we've covered memory, world models, trust, and safety. But there's one more big headache: coordination. Even if the agent is smart, trusted, and safe, what happens when there are 50 of them trying to do the same thing at once?
The Google Doc analogy in the source is perfect for this. Imagine you and I are writing a quarterly report together, but we aren't using Google Docs. We're just emailing Word files back and forth.
A total nightmare. Version control hell. I edit version 2, you edit version 2, we both save it as version 3, and my changes overwrite yours.
Now imagine 50 automated workers doing that at machine speed. That is the current state of multi-agent systems.
They don't have a shared workspace.
No. If 2 agents try to update a customer record at the exact same millisecond, you get a race condition. One overwrites the other, and the data gets corrupted.
So we need a virtual office manager.
We need a state management layer for multi-agent concurrency. a shared environment where agents can lock a file, make a change, and release it. This is distributed systems 101, but we haven't built the standard for agents yet.
And related to that coordination issue, the source talks about the ambiguity problem. They refer to a pre-flight checklist.
Oh, this is huge for anyone trying to manage API costs. How often have you given a vague instruction to a human coworker, and they come back 3 days later with completely the wrong thing?
All the time. I'll say, look into the marketing data, and they come back with a graph of Instagram likes when I really wanted regional sales figures.
But humans are usually cheapish to correct.
Yeah.
An agent running on high-end compute for 3 hours, that is an expensive failure mode.
Oh, for sure.
If it misunderstands the goal at minute 0, it burns your budget and gives you nothing. It might make 500 API calls chasing the completely wrong rabbit.
So the infrastructure needed here is a boss, a supervisor.
A meta agent, a protocol that forces alignment before any execution happens.
Okay.
Before the working agent starts, a separate layer interrogates the user. It says, you asked for a market analysis. Do you want a high-level summary or a raw data deep dive? Which regions? What's the budget? What format do you want the final output in?
So it basically refuses to start the car until you've put on your seatbelt and entered the exact GPS destination.
Exactly. It turns vague human intent into a precise technical spec. And again, this isn't the worker, it's the manager. It's the process layer that saves you from wasting money.
When you stack all of this up, the memory warehouse, the world models, trust scores, rollback, coordination, it becomes pretty clear that having a good foundational model is maybe 10% of the solution.
It's the engine. But an engine without a chassis, wheels, a steering column, and brakes isn't a car. It's just a really noisy block of metal sitting in your driveway.
The source draws a parallel to the internet in 1995, and I love this comparison. I think people forget how hard the early web actually was to use.
It's the perfect historical rhyme. In 95, everyone knew the web was going to change commerce. But if you tried to launch an online store back then, you were stuck.
There was no Stripe for taking payments.
No AWS for hosting.
Yeah.
No standard HTTPS for security.
You had to build all of that yourself from scratch just to sell a book. You literally had to run a server in your closet.
Which was impossible for most businesses. So who won that era? It wasn't just the early online stores. It was the companies that built the plumbing. PayPal, VeriSign, Cisco, Amazon Web Services. They built the infrastructure that made the web usable.
And that is exactly where we are with agents today. We're in the pre-plumbing phase.
We're staring at a massive structural gap. We have these incredible digital minds, the genius goldfish swimming in an empty bowl. They are starving for context, they're blind to the present, and they have no way to coordinate without stepping on each other's toes.
So if you're listening to this and you're a builder, an investor, or just someone trying to figure out where the puck is going next in tech,
the question you have to ask is, are you trying to build another worker? Because that market is getting very crowded, everyone is fine-tuning models, or are you building the office?
are you panning for gold? Or are you building the mine shafts, the ventilation systems, and the safety tracks?
Infrastructure is sticky. Once a company adopts your trust score system or your memory warehouse, they aren't leaving. It becomes the invisible foundation of their operations. It's boring, but it's probably worth trillions.
The boring stuff always is. I have a final thought for you to chew on. The source points out one last irony that really stuck with me. The things AI agents need most right now, episodic memory, verifiable trust, undo buttons, are the exact same things humans need in high-stakes environments.
We had centuries to build those institutions for people. We built court systems, national archives, insurance firms. We have maybe 3 years to build all of that for code.
The clock is ticking. So ask yourself, what piece of the office are you going to build? Because the workers are already here, and they are waiting for a place to do their jobs. Thanks for taking the deep dive with us. We'll see you in the next one.
Take care.